Hi, I'm Ryan Nichols, CTO at DSA Ocean, and today I want to talk about working with and setting up the Generic Frigate sample project. So the first thing you should do is make sure you've got a copy of the sample projects downloaded from the Shipmo3D website. And I've just extracted it to a folder here, Shipmo3D sample projects v4. You'll see a few projects in here. We're going to focus on the Generic Frigate to start with. So opening up Shipmo3D, the first thing you want to do is go to File and then Open Project, navigate to the Generic Frigate location, and the project file is the only one that you're going to see filtered by default here. So we see Generic Frigate 4, 4 for version 4 of Shipmo3D. Now all the data is stored in very specific folders linked to where you've got that project folder saved. So for the first time in opening these projects, you get these little messages saying directory data being updated. And it's just telling you that it's renaming it to where you've actually saved the folder to. Now the first project pane here, you'll see some basic information on the ship, length between perpendiculars and so on. There's your current directory. Then there's the application data files, and everything is empty right now. Doesn't mean you don't have any data available, it's just not linked to the project by default. So in setting up the ship model, we just basically systematically want to go through each application, create the data. Most of the time, data from one feeds into the next, so we'll get started with that. We'll go Add Existing Data, Panel Hull. That's the first one. And you'll see, make sure you're looking at the right folder here. We've got Generic Frigate Panel Hull input file here. And again, you'll get this message about the directory data being updated. Again, you only see this message the first time you're opening up and setting up these project files. So go OK. Here you can see the Panel Hull application with the information set accordingly. Patch hull input file name, you'll want to make sure you've got the right folder for this one as well. Just open it up and then make sure you're looking at where you've downloaded the file, and then you want Generic Frigate patch hull file. So that's a little change there for that input file. And we're going to leave everything else default and go save and run. It should go pretty quickly. Panel hull successfully completed. And we'll go to the, well, in a moment before we go, we'll just go plot panel hull. You can get an idea of what the mesh looks like. So with plot panel hull, there's some camera controls here. You can sort of maneuver around the ship and take a closer look at it. Note the waterline mesh is automatically refined. That happens regardless of whether you're putting in hull lines like with this hull patch file, or if you're importing an OBJ file. Note the color table. This is kind of handy if you look at ship parts. You can see the wet panel section in yellow and then the dry one in green. Just to kind of, that'll change depending on the draft that you set in the ship properties, but it's just interesting to see that. Okay, the next one is panel lid. Let's open that up. We've got a Generic Frigate panel lid file. This is for setting up the numerical lid that's used for suppressing irregular frequencies. Make sure you're selecting the wet panel hull file name in the right for this project. Just make sure that was just generated a moment ago, so we'll select that. There's a few different ways of generating a lid, and we'll get into details in another tutorial, but we'll just leave it at default for now. And you can go just run, panel lids created. You can plot the panel lid, and then it's just showing the waterline interior lid that's generated in that sort of pink-purple color in the middle. Next, what we want to do is add the radiation diffraction effects in rad diff. So we'll go to Add Existing Data, rad diff, and select the Generic Frigate rad diff input file here. We'll need to change the folder paths here and make sure we're using the wet panel hull and the panel lids we just set up. So we'll just make sure we're in the right folder here. Collect Generic Frigate wet panel hull file and the lid file here also. We're going to leave everything else default. Normally I would not recommend running diffraction calculations at the same time as radiation for the very first time and looking at a project, just to take a look at the radiation properties, make sure they look good, because the diffraction calculations will take a lot longer, and if you want to make any adjustments to your mesh, it's a good time to do it then. But that should be fine for the generic Frigate files, and it'll take a few hours to go through the computation, so just be aware of that on normal kind of computing hardware. Parallel processing helps a lot, but just maybe don't use it if you're planning on using your computer for other things, because it can take up a lot of resources. For now though, we're just going to save and then run, and we'll come back to this in a moment. Okay, so some time has passed, and typically what I like to do is look at plot radco, just to look at the radiation coefficients. Both added mass and damping show up on these plots, which is great for surge, sway, heave, roll, pitch, yaw, and then also the longitudinal and lateral condition numbers. The condition numbers are just giving you an idea of how well conditioned the numerical calculations are behind some of the various frequency ranges. For the most part, for a monohull type ship, we're looking for relatively smooth, kind of looking curves, and I mean everything's looking really great here. So I wouldn't really want to bother going back and refining the mesh or anything like that. And it also gives me confidence the diffraction calculations are going to be looking good as well. So the next step after this is assembling the numerical ship model and adding appendages, and we're going to do that with build ship. So we go to add existing data for the generic frigate. Here's the build ship input file that's pre-configured. Again, we need to go through and make sure we're adding our radiation diffraction database, the dry hull panel value. I'm going to leave the other properties just at the default inputs for the inertia properties and so on. Resistance values and some eddy drag coefficients. There's already a lot of bilge keels set up, some foils and skegs and so on. And this is where we run build ship, and it makes some estimates on the propeller RPM speeds needed for various forward speeds. All done. This is where you can also take a look at your ship model. If we go to plot ship, and sometimes I like to show the panel hull outlines as well. Now the difference between this and the view in panel hull is that you can now see the hull appendages that we've added, so the bilge keel models and things. Now these are pre-configured, so we didn't go through and create the detail in this tutorial, but you can see there are the bilge keels, the skeg here, rudder, and the foils for the propeller stays as well. Yeah, and that's primarily what you need to get everything set up to start working with the generic frigate model and start running some tests and seakeeping motions, which you can check out in some of the other tutorials. All right, thanks for watching.